what is relation? Most of the things we are going to discuss here are things you know. Just like your conventional knowledge of or about what a relation is. I can say this person, Mr. A, is my relation based on the fact that probably he is my brother or sister. We are related in a way. Do you understand? And there is always a particular condition for us to be related. Do you understand? So a relation is, in mathematics, coming back down to mathematics, relation is simply a way. I hope you are here with your writing materials, because this is a class, so you have to come with your writing materials so that we'll be able to relate very well. Okay, so relation is a way in which two or more people or things are connected. This is the general knowledge about what relation is, but streamlining it down to the concept of what we have that the relation is simply the set of ordered pairs. It is the set of ordered pairs. And when we talk of ordered pairs, it simply means that we have two items that follows a particular condition. We have two items such as x, y. X, y is an ordered pair. Later on, we would see what x stands for and what y stands for. All right. So, having said that, we have to take note that the elements in which the elements of the set A is assigned to the element of another set B by A. I have to make emphasis here, by a well-defined rule. By a well-defined rule. So this is very, very important. We cannot call, I can't be called your relation. Is that okay? Priska, I am not related to you. Do you understand? So I am not your relation. Do you get it? So what is the particular condition for me to be called a relation to you? Do you get it? I must have a link, probably through the blood or by adoption and the rest. Do you understand? So there must be a well-defined rule that the elements of set A, so comparing set A and set B, the element of set A must have with or in respect to the element of set B. Do you understand now? So when that is done, then we say that set A and set B are related together. All right, I can see that Wisdom just joined us. Wisdom, you are welcome to class. So we made emphasis on the well-defined rule. Later on, I will show you why emphasis was made on the well-defined rule. All right, so now I have talked about what a pair is. A pair of socks, pair of sandals, pair of shoes, and so on and so forth, insofar as they come in twos. Do you understand? And we said ordered pairs comes in twos, just like we saw in this case of x, y. And we said what made x and y come together is the fact that they have a well-defined rule. Okay? They have a well-defined rule. Having said that, it is important for us to know what letter or which of the letters we use to denote the relation of a particular function or the relation between two or more sets. So relations are denoted using the symbol R. okay, of which if we say the elements in set A, considering set A and B, if we say the elements in set A are related to the elements in set B, we can state it like this, that A is related to B, okay? Or we can say elements, remember I said while discussing sets that the elements in a particular set are denoted using lowercase letters. I'm sure you still remember that, right? While the set itself is denoted using the uppercase letter. So we can either say that the set A is related to set B, or the elements A of set A, is that okay, are related to the elements B of set B. Now let us take a very simple example, right? And I want you to take note of this example. Example A, or example 1. Now, we said that let set A, let's consider one set A to be equal to 1, 2, 3, and 4. Of course, 1, 2, 3, 4 are the elements in set A. And another set B to be equal to 2, 4, and 6. The question is, or the other part of the question says that R, capital letter R, denotes the sets of all ordered pairs. The set of all ordered pairs x, y. I'm sure we are still on the same pace. I'm trying not to be fast so that you'll be able to get everything we are discussing. But if you have some questions, you can. Okay, Blessing said. All right. So if you have some questions or anything you need to let me know, you can drop them on the chat section and I will look at that later on. All right. So it said R denotes the set of all ordered pairs x, y of integers. Take note, integers. Now we discussed integers as one of the components of the real number system in our first class. So that is why all the classes you missed can still be rewatched on the platform. Is that okay? So of integers such that x minus y is an integral multiple of 3, such that x minus y is an integral multiple of 3. X minus y is an integral multiple of 3. Now, I want you to take note, or let me take you back to what we said while discussing relation. We said that the set in which the element of the set A is assigned, take note, is assigned to the element of another set B by a well-defined rule. I said earlier that the condition, one of the conditions for I and let's say Love the Rose to be related is that something must be linking us. Do you understand? There must be a linking cord. The linking cord could be by blood or by adoption. Do you understand? So, but in this case, the linking cord between the element in set A and the element in set B is that the element in set B, let's look at it, is that the ordered pairs must be what? Be an integral multiple of 3. The subtraction or the subtraction of y from x must be an integral multiple of 3. Is that okay? Now let us go to solving this problem. Of course, considering the two sets A and B. Oh, sorry. So considering the two sets A and B. So we have set A to be equal to, this is the solution to the problem, set A to be equal to 1, 2, 3, and 4. Put in an enclosed curly bracket, and B is equal to, we have 2, 4, then 6. Of course, they said x minus y must be an integral multiple of 3, the ordered pair. So let us take any of them as x and y. So let us say the elements here, for us to have an ordered pair, is that okay? For us to have an ordered pair, we must have that the subtraction of the first entry, x is seen as the first entry, okay? While y is seen as the second entry. Remember, I told you that I will tell you what x and y stands for later on. Do you understand? So the set of the first entry is called a particular name, which I will not tell you now. But when the time comes, I will still tell you in this class. So x is the set of the first entry, which is called a particular name. Is that okay? While y, alphabet y, is the set of all the second entry, which is called a particular name, which I will tell you later also. Follow me closely so that you would not miss any part. If you need to drink water, you can do that now before I delve into the deep of the ocean. All right. So the first entry, let us take 1. For instance, 1 and 1 here, this 1 over here, and 2. So 1 and 2. Let us take 1 and 3. Okay, 1 and 4. Because 3 is not in the second. So we took 1, this 1 over here. If you're seeing it, I'm sure you're seeing it. We took 1 and we took 2. So A must be related to B, right? So we took 1 and 2. We can also take 1 and 4. Okay? We can take 1 and 6. Do you understand? We just want to look for a way all these guys are related. So we can relate it by saying 1, 2, 1, 4. We can say 1, 6. We can also have a relation like 2, 2. Okay? 2, 3, 2, 4. Then 2, 6. Do you understand? We took these two and gave a relation between all these three also. Do you understand? We can go on and on and on. 3, 2, 4, 3, and so on and so forth. But because of the condition which states that the ordered pair, because of the condition which states that the ordered pairs must be related in this format, that is, x minus y must be an integral multiple of 3. What is an integral multiple of 3? We can have minus 3, we can have 3. Do you understand? So the combination of the first and the second entry must give us an integral multiple of 3. So looking at this relation, we can have the A relation B to be equal to, open this bracket, 1, 4, another bracket, 3, 6. We can also have 4, 1, and also have 6, 3. Do you understand? So these pairs are related to the A and B are related because x minus y is an integral multiple of 3. Let me show you so that you see it very well. Okay? Let us say this is, of course, this is x for this ordered pair. This is the first ordered pair. This is the second ordered pair, the third ordered pair, and the fourth ordered pair. Is that okay? Now, this is x for the first ordered pair, y. This is x for the second ordered pair, this is y. This is x for the third ordered pair, this is y. This is x for the fourth ordered pair, and this is y for the fourth ordered pair. So let us check. 1 minus 4 is equal to minus 3. Is minus 3 an integral multiple of 3? Yes. Is that okay? Now let us check also 3 minus 6. 3 minus 6 gives us minus 3. Is minus 3 also an integral multiple of 3? Yes. If we do for 4 minus 1, 4 minus 1 is 3, and 6 minus 3 is also 3. So the reason why we chose 1, 4, 3, 6, 4, 1, and 6, 3 to be among the relation is because of the condition in the question, which is that the ordered pair x, y must follow the condition such that x minus y, I told you x is the set of the first entries. Is that okay? While y is the set of the second entry. So the first entry minus the second entry must give an integral multiple of 3. And that is what we have over here. Is that understood? So we've been able to explain this concept very well. With this, let us go to the next thing we have, which is domain and range. Domain and range. Kabari, I can see you. Is that okay? You're welcome. Yeah. So, while others join us, let us continue with what we have. What is domain and what is range? We've used these terms interchangeably most times. Is that okay? I think you know what domain is. Some persons will say, this is my domain. It means this is my territory. Do you understand? But when it comes to relation and function, they are not the same. Do you get? But in relation and function, the domain is the set of all first entries. Is the set of all first entries. In a simpler term, you can say the domain is the set that contains all the first entries belonging to a particular relation. Do you understand? So I would explain that in a short while. All right? So while range, if you can guess what range is. Since we are talking about ordered pair, and we have that domain is the set of the first entries in an ordered pair, of course, range is the set of all the second entries in an ordered pair. So for instance, if I have, considering this relation we have over here, considering the relation A, relation R, A relation R, A relation B, which is equal to 1, 4, 3, 6, 4, 1, and 6, 3. This happens to be the relation, right? So from this relation, we need to know the domain and the range. Okay? The domain and range. Some people confuse codomain and range. I will tell you what codomain is and how to differentiate it between and how to differentiate it from the range of a particular set. Okay? All right. If you're still with me, you will realize that since I said a set that contains all the first entries should be called the domain. So domain can be seen, can be denoted by DOM. Most times when you see DOM, it means domain. So the domain of the relation R, is that okay? Or sometimes you can write it as domain of A relation B. They are still talking about the same thing. Okay? Is equal to the set of all the first entries. So let us bring out the first entries. These happen to be the first entry in this ordered pair. This is the first entry in the second ordered pair. Of course, this is the first entry in the third ordered pair. And 6 is the first entry in the fourth ordered pair. Alright? So if we bring them out, we would have that 1, 3, 4, and 6 would give us the domain of the relation R. Is someone still following me? All right. If we look for the range, if not for time, I would have asked you to do something for me right now, but let me continue, okay? The range of R is equal to the set of the second entries. Of course, it is the set 4, 6, 1, and 3, okay? So we have 4, 6, 1, and 3. This is it. As simple as that. There is nothing, no addition, no subtraction. Is that okay? So go to the moon, come back to Nigeria. This remains the same. All right? So since we've said that, we should also note that we can represent both the domain and the range using diagrammatic representations. Of course, the diagrammatic representations, in most textbooks, you have the domain, let's say domain, we'll see all those things later on, and the range. Okay? All right, I have a question here. The question says that range, is it not meant to be the same as the codomain? Yes, that is a very, very good question from Joyce, Amarachi Joyce. She said, is range not supposed to be the same thing as codomain? Oh, most times, is that okay? Most times, range could be seen as the codomain, but in the actual sense, they are not the same. Don't worry, just calm down. I will tell you the major difference when we get there. We are coming there. We are going to get there later. Is that okay? All right. Thank you for that. I love that question. I love that question. A very smart question. Okay, want to denote this diagrammatically, the relation between A and B. Let's see how it is done. All right. We said the elements in the domain and the range can be put into an oval shape like this. Into an oval shape like this, where the element will be inserted in. So the domain, from what we have, gave us 1, 3, 4, and 6. And the range gave us 4, 6, 1, and 3. So how are these elements related? How are they related? Very simple. If you check, let us go back to it. A is related to B. Look at it. Look at it over here. A is related to B. So we have 1 and 4. We have 1 and 4 are related, right? We have 3 and 6 are related. We also have 4 and 1 are related. And 6 and 3 are related, okay? So we can decide to map them. This is called mapping. Is that okay? It is called mapping. Later on, you see, just follow me stepwise. You will get it. Is that okay? There is no magic there. There is no magic. So the relation can be, we'll now map 1. This is seen as 1, 4. Okay? We have 3, 6. We have 4, 1. And we have 6, 3. This is just like saying 1, 4. Okay? This is 3, 6. This is 4, 1. And this is 6, 3. That is the relation. Is that okay? This is the diagrammatic representation. In fact, this makes it easier for you to comprehend it. Do you understand? That is why diagrams are very, very important. It makes the question very easy. And that was the reason why we talked about Venn diagram under set. Venn diagram, of course, you know that it is the diagrammatic representation of sets. And it made our work easier yesterday. Is that okay? Now, since we've talked about this, the next thing is to go back to the question Joyce asked. She asked, range, is it not meant to be the same as the codomain? I can even sound the confusion in the voice. I'm not saying you are confused, Joyce, okay? In fact, even though you are confused, welcome. This is where we are going to clarify all confusions. Trust me, we'll do that. All right? The question is range. and codomain. Oh, are they the same? This is the question. Of course, they are not, but most times we use it interchangeably. Take this note. The set, okay? The set containing all elements in the range is called the codomain. Is called the codomain. This is, in fact, is as simple as that. There is, oh no, it's just that simple. We know that the range is seen as the set of the second entries in a particular relation, right? Since we've known that, if we have another set, okay, if you have another set in which all the elements in the range are found inside that particular set, then we call that particular set the codomain of the set, whatever set we are talking about. For instance, if we have, I told you to follow me closely, you understand it, okay? So if you have a set, which example? Let us say the range, if you have a range to be equal to 1, 5, 7, and 9, okay? 1, 5, 7, and 9. Anselm, wow, I can remember you. Anselm, welcome, eh? You're highly welcome. All right, the range 1, 5, 7, 9, all right? And we have another set, just one set like that, one set. Another set, let's say set P is equal to 0, 1, 2, 3, all the way through 10. If you watch closely, you realize that all the elements in the range, which are 1, 5, 7, and 9, are contained in the set P. So, in this case, P is the codomain. P is the codomain. But in some cases, is that okay? In some cases, note, and that was where Joyce's question came from. So, in some cases, we have that the codomain is equal to the range. So, Joyce, with these few points of mine, I am very, very convinced. I am sure I've been able to convince you that sometimes you call range your codomain, but that does not dispute the fact that range and codomain are two different things. Okay, let me ask you a question. Sometimes you call your cousin your sister, right? You say, she's my cousin. In fact, some people spoil the whole show by saying she's my cousin's sister. But does that make her your biological sister? No, she is not. She is not your immediate younger or elder sister, as the case may be. But she is your sister. So you're correct calling her your sister, and you're also correct calling her your cousin. Do you understand? It's that simple. All right. We have God. We have just barely, wow, we have barely 10 to 15 minutes left. And I just feel like dishing out what I have. I just feel like doing it. And I'm sure someone is telling me that, oh, please don't stop, don't stop. But we have to stop because we have physics class after now. And I'm very sure all of you will be a part of it. Okay? In fact, I'm already seeing you in the physics class already. I'm already seeing you in the physics class already. All right. Okay. Let us look at another concept before I think we'll not be able to consider the properties of relation for today. Probably that's where we're going to start or kick off from in tomorrow's class. Okay, someone is asking, will there be class tomorrow? Start today. Is there any time you don't learn? Don't worry, that will be passed across to you later on. So let us talk about the inverse of a relation. Inverse of a relation. If I have a particular notation, let us call it A. A equals 5. A equals 5. I want to find the inverse of A. The inverse of A is simply put A, okay, and put something like minus 1 on top. That is just the inverse of A. And this minus 1 denotes that, see, whatever is below this particular number we have here, which is 5, take it to the top of it and divide it by that same number. Of course, what I'm just trying to say is 1 over 5. That is the inverse of 5. 5 on its own is equal to 5 over 1. Sure you know. I'm sure you know that one. So the inverse of A is this invisible one that was here. Take it up. Do you understand? Take it up and then bring 5 down. That is the inverse of A. Now, bringing it back to what we have, talking about relation. Remember we said relation is the set of ordered pair x, y such that the elements or the set A, they are linked together with the elements of set B using a well-defined principle or rule. So since we know that the set R is equal to the set of x, y. If we have another set, let's call it set Q, a random set Q. You know I told you that X is the set of the first entries, right? And Y is the set of the second entries, okay? Now, if we have another set Q, in which the first entries assumes the position of the second entry, okay? And the second entry assumes the position of the first entry, then we say that that particular set is called the inverse of the relation. Do you understand? Of course, we call them relation because they are related. So if you now interchange them and say, okay, y take the place of x and x take the place of y, then what we've succeeded in doing is to find the relation of that function. It is as simple as that. There is nothing more, there is nothing less. Is that okay? So if we have something like y, x, then we say that Q is the inverse of the relation. All right. So considering the relation we had earlier, we had the relation R is equal to the set of ordered pairs 1, 4, 3, 6, 4, 1, and 6, 3. So the inverse of R is written like this, which will be equal to 4, 1, okay, 6, 3, 1, 4, and 3, 6. That is that about that. With this, we have come to the end of today's class. I am very sure you have questions for me. I am very sure. Okay. Oh, Joyce again. Joyce said, are there rules applied when looking for the inverse of a relation? Of course, there is a rule. Is that okay? There is a rule, and the rule is, in fact, the simplest rule, or the most basic rule, is that your range will now assume the place of your domain. So whatever you used, whatever method you used to solve for your range, is that okay, will be inverted and considered for the domain, and vice versa. That is the basic rule used to convert a particular relation to its inverse. It's as simple as that. Is that okay? All right. So that we would have ample time to prepare for the physics class. If you have not told anybody about this class, make sure this little time I'm giving you, you reach out to all your contacts and tell them, see, you are missing a lot. Just like Jotam did today. Okay? You're missing a lot, because if you're not informed, definitely the formation is inevitable. So inform your friends, inform your roommates, inform everybody. In fact, everybody. The live classes are free. You're not paying a dime. In fact, it says salvation is free, but someone paid for it. These live classes you're talking about, the free live class, someone paid for it. And I don't want that person's money to just be a waste. Okay? So call your friends, let them come and enjoy a nice time studying with AWOKO. So I will see you in the physics class shortly. Okay? So do have a nice 10 minutes to yourself before the next class. All right, see you in the physics class. Joyce, Anselm, Wisdom, Ibifiri, Jotam, Kabari, Blessing. I'm super excited to have you in the class. Mercy just joined. Wow. Mercy, you are welcome to class. Okay? But we have just ended the class. All right? I'm sorry. You can join us in the physics class. I just saw a question here now. It says, please, is when on inverse, does the x, y change position? Okay, when talking about inverse, if I get your message correctly, it said when talking about inverse, does the x and y change position? Is that your question? Okay, you can, don't worry, we will continue relation and function tomorrow. So you can rephrase your question and bring it on tomorrow. We'll talk about it so that we'll not enter into the physics class. So see you in the physics class. Favor, you're welcome to. We'll see in physics class. Bye.